Every time you Instagram a picture of the foam art on your coffee or leave a comment on a YouTube video, it contributes to the more than a billion gigabytes of new data we produce every day. As this number continues to increase, we are starting to run out of space to store the data. Even the tiniest data storage element uses thousands of atoms to store one piece of information. Now researchers have found a solution to this data storing problem, a 3D diamond chip that will be able to store vastly more information than current technologies. Typical home computer hard disk drives consume a lot of power and are limited to a few terabytes of storage per drive, while optical storage media like DVD and Blu-ray are energy efficient and cheap, but cannot store huge amounts of data. In order to get around this problem, scientists at the City University of New York looked into how a unique feature of diamond could be used to create storage technology. They claim that diamond-based storage could hold 100 times more information than a DVD. Without better solutions, we face financial and technological catastrophes as our current storage media reach their limits. Co-first author Dr. Siddharth Damkar wrote in an article for The Conversation, "How can we store large amounts of data in a way that's secure for a long time and can be reused or recycled?" In our lab, we're experimenting with a perhaps unexpected memory material you may even be wearing on your ring finger right now: diamond. On the atomic level, these crystals are extremely orderly, but sometimes defects arise, he said. We are exploiting these defects as a possible way to store information in 3 dimensions. The nitrogen vacancy center is a defect in diamond, which occurs when a carbon atom is replaced by a nitrogen atom in the repeating structure. This creates a vacancy or hole next to the nitrogen atom compared to the rest of the lattice of carbon atoms. Nitrogen vacancy centers have a tendency to trap electrons, but the electron can also be forced out of the defect by a laser pulse. Professor Carlos Mariels and his colleagues used optical microscopy to read, write and reset information in a diamond crystal, making use of this defect. But in our lab, we instead look at these nitrogen vacancy centers as a potential benefit, Dr. Damkar said. We think of each one as a nanoscopic bit. If the defect has an extra electron, the bit is a 1. If it doesn't have an extra electron, the bit is a 0. This work reveals the unique opportunity of utilizing atomic-sized defects for high-density data storage, transforming the beauty of physics into a vastly useful technology, said Dr. Damkar. Speaking to the future real-world practicality of their innovation, Mr. Jacob Henshaw, co-first author, said, "This proof-of-principle work shows that our technique is competitive with existing data storage technology in some respects, and even surpasses modern technology in terms of rewritability. You can charge and discharge these defects a practically unlimited number of times without altering the quality of the material." Dr. Marcus Doherty from the Australian National University, who was not involved with the CUNY study, said in principle, their technique could achieve higher information densities by encoding binary information on the spin rather than the charge of NV centers. This is an exciting instance where the quest for next paradigm quantum technologies has yielded a novel advance in today's classical technologies.